Welcome to this week's Tech Tip, where we'll be taking a look at how to access the machining cycle time calculations. For this demonstration, we'll be using a part file that already has toolpath created, and we'll be exploring the different options for cycle time reporting, as well as how it can be used to help improve the program. First, let's take a look at the overall cycle time. If we hover the cursor over the header for the sequence, we can see that the full cycle time is displayed. We can also see this information if we go to the Verify drop-down on the Machining tab and scroll down to cycle time on the list. This will send the cycle time information to the feedback window, where it will remain displayed as long as the part file is open, unless we manually delete the data or right-click and select Clear. It's also possible to look at cycle time for individual toolpaths. If we right-click in the workspace, we can see that by default IntelliSnap is on, and as long as IntelliSnap is active, if we hover over an individual item, we'll see a tooltip pop up that shows us what layer the item is on, that it's a face mill operation, that the feature is machined in the top CPL, that the cycle time is approximately 1 minute and 6 seconds, and that there are 67 elements or moves that make up the toolpath. If we use IntelliSnap and hover over the profiling operation in this file, you'll notice there's a tab symbol above the tooltip dialog, and the top line of the tooltip shows item 1 out of a possible 8. This lets us know that we can use the tab key on the keyboard to cycle through the 8 available items so that we can see the toolpath that we're interested in seeing. The cycle time for this roughing operation is 34 minutes and 11 seconds with roughly 1900 elements in the code. Another way to see the same information is to use the Verify Entity command located in the Quick Access toolbar. We can select the item that we're interested in seeing. When we select Done, the cycle time information will be written to the feedback window. It's worth noting that the same Verify Entity information can be accessed from the Verify list. When accessed from the list, you'll notice that you'll have a precision field that allows you to override the system precision. Unless you have a specific value in mind, it's best to leave this blank so that the system precision is used when the Verify Entity report is created. A third way to look at this information is to use the timeline window. So if I go to the Windows list and select Timeline, you'll see the timeline window open in the bottom of the workspace. In the timeline window, we see the total cycle time for the job, as well as the individual items that make up that cycle time. If by default the timeline is too large for the timeline window, you can double-click in the blank white space and it will resize the timeline to fit the window display area. Notice now that we can see the total cycle time of about 78 minutes and also easily identify the items that impact that cycle time the most. For example, we wouldn't want to spend our time editing this rest roughing that doesn't have a big impact on cycle time when there are other items like this roughing operation that has a significant impact on cycle time. I'd also like to demonstrate that the timeline window can be unpinned so that it stays at the bottom of the workspace and pops up as needed. Notice on the timeline that if I hover over this item, the toolpath highlights on the screen and it tells me that it's a roughing operation. Now if I right-click this operation, I get the same action list that I do as if I right-click in the sequence window, and I can select Edit to open the roughing dialog. When we look at the feed rate for this roughing operation, we can see that it's far slower than it should be, especially when using a waveform strategy. So I'll adjust this feed rate by a multiplier of 10, and that should significantly reduce our cycle time. When we look at the timeline now, we can see that the total cycle time has been reduced to just over 48 minutes, and the roughing operation that we just edited is much shorter. If we want to see exactly how much the cycle time has been reduced by, we can again use the Verify Entity, select our roughing operation, and we can see here in the feedback window that the cycle time is now 3 minutes and 46 seconds as compared to the previous 34 minutes and 11 seconds. So we've made definite improvements to the cycle time using the 3 tools that we have available to us. Once we're happy with our cycle time optimizations, we're ready to generate code. You'll notice here that we have a job name selected. The point of this is to illustrate that the information contained in the program is automatically updated to the toolkit so that it can be used later in the job reports. So now that that's done, let's open up the job reports, and you can see that the top job on the list is the one that we just posted. In the job report, we can see the total cycle time, and if we go to the job instructions list, we can see that the software picks up the cycle time for each individual item in this list. We expect these cycle times to be reasonably accurate since they're generated using information in the post-processor that's unique to the machine, such as machine rapids, feed rates, and other information.